Okay. Hey. Okay, is that better? Alright, that's probably better. Hello, hello, hello. Why isn't this working? Where's my camera? Oh, God. Yeah, now my camera's not working. Oh, there we go, I think. Love technology, hey? Okay, let me start again. Guys, welcome to week 10, lecture 1. I can't believe it's the final week of lectures. I can't believe I've been with you guys all for 10 weeks. It's gone really, really fast. I hope you've had a good experience wrapping up iteration 3. I know for a lot of you maybe it was stressful, especially with the Easter weekend falling right at the end of it. Unfortunately, there's just really not much we could do to skirt around that. But the upside is that it's submitted now. You've all done an incredible job. Like iteration 1 and 2, what will happen now is your tutors will work with you over the next week to sort out any final issues that might have occurred, and hopefully you get the spirit now that the tutors are really there to support you and work with you. So if there were any small issues or hiccups along the way, we have some recourse for fixing that up. So special consideration and just even reruns and final clarifications and things like that. So if anything's happening and you think, I don't really feel like this is fair, that's fine. Just make sure you reach out to your tutors and have a conversation with them this week. And we are on your side, so we will work with you to fix that up. But really, congratulations. I mean, you've done an amazing job so far in 1531. And I hope if you look back on what you've created at the end of these 3 iterations with your team, with your group, that you feel really proud about what you've created, because it's a significant product that you've built in your team. And more than what you've built, you've learned how to write code collaboratively with your team using Git and some agile principles. You've really done an amazing job. So congratulations. If it didn't go as well as you wanted for iteration 3, again, make sure you reach out to your tutor and at the minimum have a discussion on what went wrong, and maybe your tutor can come up with some ideas for some recourse, I suppose. But what matters at the end of the day is what you've learned, and I think you've all learned a lot. So congratulations again. Any questions on iteration 3, I suppose, before we talk about some other stuff? Did you see the peer review form went out this morning? So make sure you complete that. You've got a week. There you go. I've just bet you, Fatima. So yeah, the peer review form, I sent out the link this morning. Did everyone get it? It should just be on WebCMS. Oh, is it not? Oh, maybe I didn't send it. Oh, I mustn't have. Why don't I just do that now? I mustn't have. Oops. That's weird. I'm sure I did it. Okay. I made it, and then I just didn't send it, I suppose. I bet it's like in a tab somewhere. Oh, doesn't matter. I'll just quickly. You get to see behind the scenes how these iteration 3 peer review. Please complete by Sunday 10 a.m. Earlier is better. Any other information that needs to go out in that? This is like, by students, for students announcements. All right, it's going out. There we go. Sorry about that. And then I guess I can just give you the link. Response page. No, that's fine. Oh, God. I shouldn't call it the response page. Yeah, that's fine. Scary. They scared me. Okay. Yeah, exactly, Jay. We'll do lecture revision tomorrow. Exactly. Okay. All right, so that's done. Thank you for bearing with me. But I mean, that sort of fits in today's sort of mood for what I imagine for today's lecture. There's some content stuff that we can talk about, like the iterators and generators that I have on the screen now. But it is completely bonus. So none of it will be accessible. It's not going to be in the exam. It's not going to, well, obviously it's not any project work or lab work because the projects are over. It's just some fun to have there, stuff there. But some more important stuff. Let me put this over here again. Okay, before we do anything, the most important thing for all of you to do right now, and for all of you watching, I don't know how many of you there are, but please complete the student satisfaction survey that's on the screen right now. I don't think I've put an announcement about it yet either, but as you may have known, this isn't your first term studying at UNSW or at other universities as well, but the student satisfaction surveys are really, really important for us, for the school, for the university, to understand the health of the courses, how things are going, how, you know, it's the main mechanism to collect formal feedback. You've been giving lots of feedback via our forms throughout COMP1531, and I thank you for it. But those are mostly for me to like make small adjustments as I go to just improve the quality of the course, and hopefully you saw that if you were someone that left some feedback. But this is sort of a bigger scope thing. Yeah, there's lots of ways to approach it, but it is just really important. Yeah, my experience is what I'm talking about. Sorry, Fatima. So can you guys let me know if you scan this QR code? I'm not actually sure how it works, but if you scan this QR code, does it actually just take you to the right page? Let me just bring the chat up over here, because while we're just chatting, it's easier for me to read it. So can some of you just let me know how that QR code's working? I mean, does it work? Because I tried it, and then I think because I'm not a student, it just says, get screwed. Cool. Thanks, Alex. Anyway, so basically, the short of it is, if you could fill this out right now. So every single person watching the lecture, right now, if you haven't filled out my experience, you know, I'll post the link in the chat as well. I don't know why I didn't just do this, so you don't have to scan the QR code. Yeah, sorry. I'm beating you to the comments today. So please, right now, super important, click the link in the chat, scan the QR code, do whatever you want, and we'll give everyone 10 minutes to complete the My Experience survey. They're really, really important. And Panjay, what you're saying is exactly spot on. So there are certain things in terms of feedback that I can't, or not feedback, but there are certain decisions that I don't make, right? For example, face-to-face lectures. But this is the sort of stuff where the whole university sort of gets access to these My Experience results. So if there's things like that you want to see changed, for example, in-person lectures to some extent, obviously it's not simple, but this is a place that you can put it in. So please fill out the My Experience form. We can put some My Experience background beeps on, but we probably don't need to. Yeah, Tom, you're a precog. Thank you for completing the form. Yeah, it's really important. Yeah, it's really important. So I don't know how long roughly it takes, Tom. 5 minutes, 10 minutes? I don't think it's very long, so I'll wait. Awesome. Oh, and also, when you do the form, I think it will tell you, but there's like sort of 3 ways to think about the form. It's things for the your tutor, so feedback for your tutor, experience of your tutor, experience of me as the lecturer, and experience of the course, right? They're the 3 sort of distinctions. So just make sure you're trying to think about that distinction. But the questions are really straightforward. You don't need any help. Let's see. Can I see the are the stats going up? 8% response, 9%. We've gone up 1% point. Fantastic. While I do that, I can probably just continue on the theme of spamming the announcements. So let me do this. Excuse me. Oh. Sorry, let me read the chat. In pre-pandemic days, we used to have more than 200 students turn up for lectures. It used to be a very different experience, but now everyone likes to watch YouTube recordings. It's true. There are benefits to the recordings, I think. But yeah, I don't know what the future is going to look like. I think it'll be somewhere in the middle of what we have today and what we used to have. It's interesting. We can have a discussion about it, really. I'm interested to hear your thoughts as I go on to teach other courses and this course again, what you guys liked about it and what you didn't like about it. In fact, I already wrote some copy for this. Let me just... Okay. Okay, let me know how you guys are going with it. Do you need a bit more time? No rush. We've got all the time in the world today, really, so I just sent that link out. What did I just do then? Ah! Yeah, the travel time's a big one, Tom. I think it gives it, yeah, look, it's complicated. Yeah, it is complicated. In fact, while you guys are completing that, I'm going to let the tutors know. Ah. Yeah, pretty much. No, you're not going to do it for 2 hours. We're almost done. You guys just let me know when you've finished the form, and then we'll move on. Are you allowed to complain about Tamagotchi? You can complain. I mean, you can complain about whatever you like, but do keep in mind. I mean, you can complain about it, but maybe try and pick a little. Yeah, I heard the feedback about Tamagotchi. I think it's gone, to be honest. So you can put it in, but yeah, I think the lab's gone. We did hear the feedback from the forums primarily, so maybe it can be kept, but just fixed up with how the tests work. But guys, let me know how have you completed the my experience. Yeah. I'll fly to Sydney next term, don't want to watch online courses anymore. Yeah, fair enough. I mean, hopefully there's some, especially as you get in the, go on in your courses, the lecture sizes should get smaller, and so it'll be easier to run them in person. It's these big first year courses that are a bit harder. Alrighty, is that enough time, everyone, or does anyone need a few more minutes? Otherwise, I should quit this. Give me some feedback, people. Do you want me to move on, or do you want a few more minutes? For those of you who have already done it, I apologize. hearing much from you all. Don't know if that's a good or a bad thing. %. Cool. It's jumping. All right. I think we're going to move on. Does that sound good to everyone? End the poll. No, Fatima. Nope. Property-based tests will not be assessed. I removed them from the curriculum this term. So I think there was one optional lab on them, but they're not going to be in the exam. Alrighty, are we all good to go on? Give me some feedback, people. Otherwise, if you need a few more minutes, I can leave it, but I can't tell if no one tells me. I think I'm getting addicted to this chapstick. I need to get rid of it. All good to go? Okay, fantastic. I'm gonna just take that and run with it. Okay, so to clarify again, the main content today is kind of obvious what my answer is. I don't know what that means. I don't know. Hopefully you mean positive and not negative, but done. Awesome, fantastic. Okay, thank you all very much. All right, let's get into it. So again, once again to clarify, the content today is, we call it bonus. We're not saying it's not relevant, but we're saying it's not going to be assessed. The reason being is that the project is done now. That's the main chunk of content that we want to be accessible and what we want you to understand. However, there's lots of stuff we can talk about. And this is some interesting stuff that we've sort of been using that's sort of relevant. We can talk about it a bit today. So keep in mind, keep in mind it's not going to be on the exam. Obviously, there's no other way. There's no labs. There's no labs on it. I'm almost certain, but it's definitely not in the exam. All right, so iterations or iterators and generators. What are we talking about here? Click. All right. So before we get into it, there's a link here. Actually, let me copy the link for you all. But don't watch it now. You can maybe open it in a tab and save it. So Evan, a few years ago, gave a really good talk on this topic in a little bit more depth than we're going to go into. And obviously it's a different person taking a different take on it. So it's just a different approach. So if you're really interested in this stuff, you can go ahead and watch that video lecture after today's lecture. But basically, so iterators. So iterators are a concept in software development languages like Python. However, they don't really exist in all languages. So for example, C that you did in 1511 didn't really have a built-in concept of iterators and generators. Although you could sort of build stuff similar, right? So the key thing here is that, and this is why we have to talk about the bonus lecture on classes and objects in the past, because all iterators are objects in Python. I mean, if you think about it, that shouldn't be a big surprise because everything in Python is an object, and iterators are no different. So we're going to be talking about right now iterators very specifically. And in fact, you've been using iterators a lot. Since the early weeks of 1531, you've been using iterators. Anytime you've used a for loop in Python, you've been iterating over an iterator. We haven't really explained it that way. We haven't really said it explicitly. And you likely didn't think about it that way because in something like C in 1511, you use for loops all the time, but you're not really iterating over an iterator. You're just doing something over and over. You're repeating code. It's no different in Python in that you're still repeating code, but what you're iterating over, the concepts behind it are a little different. So let's get a really quick example here. On line 1 in this snippet, we have a list. That should be nothing new to you. It's just a classic Python list. And then on line 3, we can actually build an iterator from that list using the iter, this thing here, the iter function. And this actually creates an iterator object for us. But even before we do that, there's ways that we can, use a for loop to iterate over that list. So basically, there are some built-in Python things, that being data types and objects, that are just naturally iterable. And that, for example, the most obvious example is a list, because you can iterate over each element in the list one by one. So we can actually, let's run this. Let's run this. Let's see, that's the wrong code editor. Here we go. Iterator. This is fine. Yep, this is fine. Let me zoom in a bit. Oop, maybe too much. Oh, is that looking good? So, and let me just clear this. So here we have, this shopping list. So shopping list is just a list of some strings: apple, banana, or pineapple, and orange. And then we can create an iterator from that list. And that's because basically Python knows how to convert lists to iterables. So there's just the natural built-in sort of logic for Python to know that if I've got a list, I can convert this to something iterable using the iter function. It even says that if we read the Python documentation for the iter function, we can get an iterator from an object. In the first form, the argument must apply its own iterator or be a sequence. This is talking about the two ways that we can call it, but we don't have to worry about it. Basically, we get back an iterator object from something iterable, for example, this list. And then we can use the iterator to do what we need to do. So for example, we have this infinite loop here. And while we're looping, we can try to get the next item from the iterator and then print it out. If we come across the stop iteration exception, so for example, if we run out of things that we can iterate over because we've reached the end of the list, what do? We just break. So if we run this code, Python, what's this file called? Iterator loop. What we should just see is an error. Cool. And that's fine. What's going on with this? Python iterator loop in 10.1. Can anyone, why is it on the O specifically? Okay, so I feel like something's weird here. It's even telling me there's an error, but I'm not seeing. Oops, let's just, what if we just, oh, that's not what I wanted. Copied, it says. No, it doesn't want to copy it, all right. Okay, oops. Let's just save this to iter demo.py. Alright, let's see. Am I doing something stupid or? Okay, that worked. I don't know what's going on. Maybe there's some weird characters in this. Okay. So we create an iterator from it, and then we can pretty much just copy this underneath, but we go through this animal iterator. Exact same thing, just different strings. That's fine. While true, okay, print item, yep, cool. All right, if we just run that again. All right, yeah, really, I don't know what was going on with this. If anyone's got any ideas, let me know. But exact same example here. We created animals. Animals is a list of these 4 animals. We turn it into an iterator, and then we can use the iterator syntax to manipulate the iterator. So if you think about it, right, nothing happening here is any different from what would happen if we just used, for animal in animals. Oh, there's no brackets there. Print animal. What we should say here is we would get the print of the 4 animals twice. So nothing different is happening sort of in terms of the output. What is different is that in the first example, basically there are built-in tools in Python to interact with iterables or iterators. But we can go under the hood and look at, well, what does a for loop in Python actually do? And what it actually does is something more like this. It unpacks an iterator and uses the built-in functions that are always available on iterators to interact with the iterator. So what's sort of really happening in a for loop in Python is that we always use an iterator or something iterable in the for loop. That gets unpacked into an iterator using something like iter, which builds an object that has some functions on it, such as next, and it's got some others too. Then we just basically wrap it in an infinite while loop, and we try to read each element in the iterator until we no longer can, at which point we just stop, and whatever we're doing in that for loop is whatever we do in this while loop. But this is really cool because we get to take one more step back in terms of abstractions and see what's actually happening in a for loop. And this also sort of explains why so many different things can go in this place of a for loop. What can go in this place in a for loop? Basically anything that's able to be turned into an iterator. And an example is a list. Can you guys think of some other examples of things that can be turned into iterators? You might not know sort of explicitly the enumeration of things that are iterable, but can you think logically about something that you know or you think might be able to be turned into an iterable? So just type in chat right now, excuse me, if you can think of any other ideas. So Felix has got some cool ones. A vector, a queue, a class. Panjay's mentioned a dictionary. Exactly, we know we can loop over dictionaries. That must mean that there is some built-in way for Python to take these things and turn them into iterables using this iter function, or by just manually defining a custom iterable, and that's something we can look at in a moment. Another really sort of simple example is it doesn't have to be a list, it could just be a tuple. This should just work all the same. We turn this tuple into an iterator, and then everything just works in terms of using it in a for loop, whereas something in the Python logic, in the Python code base will turn this into an iterator and then iterate over it, or we can just naturally turn it into an iterator and then iterate over it using the next function. So the real key part of this, when we're doing it ourselves, is this next function. It calls next on the animal iterator that we built, which gets the next element in the iterable. So yeah. Okay. All right. So we looked at how to manually interact with these iterables. And actually, just to take it a step further in breaking it down, right? What I can also do is if I can just get rid of this loop. Let me get rid of this for loop. I create my iterator, sorry, and I can just call next on that iterator. And then I think I should just print it. Now, I don't know what will happen if I just print this out like this. Okay, we get the actual iterator object out. There's a way that I can call, is it just iter? No, that gets the iterable. Let me just quickly get up some lecture code. That one, squares, is it? Okay, you know what, actually, I think we just print the next. I think that's all it is. Yeah, cool. You can see in this example, if I clear the terminal and run it again, I get my tuple in this case, but it could have been a list or whatever it is. I turn it into an iterator, or an iterable, sorry. No, I'm turning it into an iterator, it says it right here. And I can just manually call next sort of manually whenever I want to, and I will get out that dog. So if I were to run that exact line again, what am I going to get out? I'm going to get out the cat. If I run that one more time, I'm going to get the chicken, I'm going to get the sheep, and then I'm probably going to get some sort of error because I've reached the end of what is iterable. Okay, so I just wanted to point out one more time that what we're actually doing here is building an object that's got these functions like next, and we're going to talk about the other ones it's got. And I can just call them to go manually, step by step, over the iterable. It's really cool. What do you guys all think? All right. Now, when I called that iter function and I built an iterable object, Python knew how to turn a list into an iterable object. But I can create my own, right? Let's say I've got some data structure, or I've got some data, or I've got some concept that Python doesn't automatically know how to turn into an iterable. We can just define what the signature for an iterable looks like, build that into the object via the class definition, and now I have something that's iterable, which is really, really cool. So what has to be in an object for it to be iterable? Three things. The initializer sort of is always in a object in a class, that's fine. So it's really only sort of two things, the iter function and the next function. So let's go to the squares code. I think this one's probably fine, yeah. Oh, actually, what's in this one? I don't know why there's two examples. I think they're both doing the exact same thing. So this is fine, okay. So what we've got here is sort of two things. We have a class that we've defined called a squares iterator, right? So this is a from scratch class in Python. If you remember the classes lecture from last week, you'll remember what we're doing here is creating the definition of what objects of this type will look like. So square iterator objects will have something called I, right, which is an integer. That's probably what the I stands for. And then they've got an initializer and a function called underscore underscore iter underscore underscore and underscore underscore next underscore underscore. So why does it, so I mean, maybe question one to throw to you all, why are these functions wrapped in double underscores? Why is that important? Is it important? Is that important? Oh, damn, I can't bring the chat over when I'm in full screen. So Feron, because it is a function name of another thing. Can we be a bit more can we be a bit more explicit with what we're saying? So Pernj says because they are methods and only take self as an argument. Feron says like they're going to be duplicated name kinda. Sort of some stuff here that's making sense, but sort of some ambiguity here. You won't know what to call it. So the first thing is that you've seen the double underscores before, right? If you remember, we always had like something like if name is equal to main. We had something like this, right? Which is saying that if the name of the module is the main directory, then, or the main module, then we're running this script from the command line directly. But in Python, what the double underscores mean is that this is a reserved name for something that Python needs to know about. And Python does not want the user space identifiers to clash with the identifiers that it needs to know about, or it should know about. So basically, whenever you see double underscores in Python, what it is saying that this is something that we don't want to be accidentally clashed with because it's important to the underlying functionality of Python. So basically, all you need to think about is that these are reserved. These are reserved method names for Python. Now, why are these reserved? So initializer makes sense, right? We need a specific method that Python knows when to call to initialize the objects. So it's called init, wrapped in double underscores. Iter is another reserved keyword for a method on an object, on a class, that says, call this function if you need to know how to return an iterator. Okay? And then next, similarly, is call this method if you want to return the next sequence in the iterator. So basically, when we call next here, it's calling, it's calling underscore underscore next. Well, it's trying to call on animal iterator. So it's like the map between the next function that accepts an iterator to the next availability on the object. Why isn't it just this? Someone have a whatever it should be here. Why isn't it just next like this? Why wrap it again in the double underscores? So I sort of just explained why, but can someone rephrase it? Because there's nothing stopping Python from saying, okay, if you call next on an iterator, then call the next method. Why is it mapping it to double underscore next double underscore? Any ideas? Don't worry if you're not sure, just give it a go. Oops. Yeah, exactly, Alex. It's just so, well, Alex has said to identify that it is a reserved name that Python knows what to do with it. Pretty much, it's just so that someone doesn't write an object, write a class, and next could be used for some other things that the developer wasn't thinking about the iterators. It's just so that it doesn't accidentally call someone's next method that does something different. So it's a reserved method. You can use it for the wrong thing, but if you're using next wrapped in double underscores, what you're saying is I'm explicitly going out of my way to use the specific Python method identifier for a next function iterator. Tom says, so you need to make sure the Python knows it's reserved special kind of method path it specifically handles in a specific way. Absolutely, Tom, 100%. That's pretty much it. All right, but the short of it being is that as long as I have an object with these functions on it, it's an iterator and I can use it as an iterator. So here we're going to actually do that. Use it now. So we create a squares iterator from initializing this object. And we spoke about this a little bit in the classes lecture last week, but basically I create an object from this class definition. So what I have here, if I just print squares, what I'll have here, and let me just comment that out, what I should have is a squares iterator object. Whoops, let me just run, this is called squares. That's not what I wanted. That's because I'm in Sol. Yeah. Solutions squares. Okay, and that's exactly what we have. We have a squares iterator object. This object happens to have a few methods on it. Next, iter, and init. Which means, because it's got iter and next, it is an iterable, it is an iterator. An iterator is just any object that has the presence of iter and next wrapped in double underscores. Which means we can, okay, this means a few things. So the first thing is that we can, I mean, I hope you're sort of starting to see the cool, I don't want to say magic, but the real, you know, the interesting value here. But the first thing it means is that we can just use this next pattern. So I can just go print next on squares. Let's say I do that 3 times. What am I going to see printed out? Well, we can have a look. When I initialize this object, what is the I value going to be initialized to? It's going to be initialized to 0. Nothing magic happening there. So basically what I have is this integer initialized to 0. When I call the iter function, I'm just returning myself. That's fine. Myself is just an object with this integer and with this next method, as well as iter and init. So that's also fine. When I call next, what do? I look at that integer that was initialized to 0 when it was created, and I add 1 to it. So now, you know, I will go from 0, then to 1, then to 2 every time it's called, but only 1 at a time. So let's just go like this for now. But I don't return that. I don't return 1. What do I actually return? I return I times I. So in this case, it'll be 1 times 1. This is for the first time we call next, which is obviously going to be 1. All right. So what I should expect to say, let's just do it for the very first time. If I call next, I'm expecting to see a 1 get printed out. And that's exactly what we see, other than we printed the object itself. We see that 1 printed out. Right? Any questions so far before we keep going? Now, if I print the next, I guess, 1 is going to be incremented to 2, and then 2 times 2 is going to be 4. So we are saying here that we're getting the squares printed out. Similarly, if I call it a third time, we will get the next square number, 3 times 3, for example. Okay, so we have this ability to call next and generate the next value in the sequence of square numbers, which means we could use this while loop pattern that we saw from earlier, right? While true, get the next number out of squares and print it. And if we come to the end of the iteration, we stop. However, in this case, the stop iteration is never going to be called because there is nothing built in here that will stop it. So why don't we just say why don't we just say I equals 0 while I is less than 100. So let's just loop, let's just do it 10 times. So let's just loop 10 times in a loop calling next. In fact, we don't even really need this stop iteration in this example because it will never stop because there is no stop condition. And if we run that, we're going to get, I didn't increment I. I can't do that in Python. Okay, now we should actually see 10 get printed out. Cool? All right. Okay, let's pause there for a quick second. Are there any questions so far? So we can see that we've built this object that has a way to go next and generate the next iterable or retrieve the next iterable value. And then we can use just the next function basically in a loop to go through a certain number of times and get the values out. Any questions so far on what we've done? Okay, I'm going to assume the silence means no, so let's comment that out. Let's go back, let's uncomment this. All right, now I think here's the cool part that hopefully if it hasn't already connected with you yet, it will now. Python already has a special built-in way to interact with iterators, and that is the for concept. You can iterate over a list, but you can also iterate over something that's iterable, like our squares iterator. So as long as we have an iterator that we generated called squares, we can say for, number, or we can call it a square. For a square in squares, print the number. We will need to say, however, that we need an end condition, right? Because otherwise this is going to loop forever. So we can just say that if the square value that we generate is over 1,000, let's break out of the loop. But this is so cool because, we can even sort of do it without, actually, I don't know if that'll work. So let's not do that for a second. We can test it later. We got to generate it first. All right, and then if we print square, we can see that we generate a bunch here up until the value gets over 1,000, at which point we stop. But isn't that cool? We looped over using a for loop, the built-in for loop. Well, it's not really, this is the thing in Python, it's not even really a loop, it's just a thing that knows how to interact with iterators. And we can use the built-in one that we use just like we use in anything to interact with our own custom iterator. So if you've got, this is the key thing to take away when it comes to writing a clean Python code, right? Scalable, really nice Python code. If you have built any data structure, any object, any type of thing that is naturally iterable in that you can go forward in some sort of progression. So in a list, for example, you're going through each element in the loop. In something like this squares example, it's not that you have a list of things that you're going through, you can actually generate them on the fly every time you go next. But if you've got anything that's logically iterable, you can actually just give it these two special methods, as well as the initializer, which you'll always have, and it will be able to be understood by the built-in Python tools, for example, for. I think that's really, really cool. Do you guys see that? So Tom says that's pretty neat. I do appreciate that Python's for is seemingly smarter than I am. I don't know if it's smarter than you are, but it is really cool. It means that you can abstract away the implementation of certain data structures And then to utilize them, to use them, to iterate through them, you're just using the syntax that every single Python developer knows and loves, you know, for something in something. And so behind the scenes, this for in Python is calling iter to create the iterator and next to get the next value out of the iterator. Pretty cool. Chat's really quiet today. It's making me sad. How many people are here? All right. Okay, and I actually went ahead here and we already just spoke about that. You know, for iron squares. Yeah, we literally just did that. Okay. I think, yeah, this is the last slide on iterators, and then we'll have the mid-lecture break, and then we'll keep going. So basically, I've sort of tripped myself up a little bit in this lecture on this as well. So let's be clear on the difference between an iterator and something that's iterable. So an iterator stores the state of the iteration, for example, where it's up to. So it knows, for example, how many times next has been called and what the next version of next would be. But something is iterable if it can be iterated over. So a list is iterable, but sort of by default, a list is not an iterator. You have to create an iterator from it. That all happens under the hood, but the thing to keep in mind is that something is iterable if it can be turned into an iterator. Once it's turned into an iterator, it then has the next and the iter methods available. Whereas iterables only have a way to convert it into something that's an iterator that has the introduction of the next method. Does that sort of make sense? If we look at our code here, for example, when I create a squares iterator, it is already an iterator because it has this next method. But you can imagine that I've got some other class X that, you know, whatever, self, whatever. And, you know, maybe it's got some array here, and then we can say that, okay, if you want to turn it into an iterator, that's fine, here's how you do it, and this returns something random, you know, that goes off and adds this next method. But by default, class X does not have the next method on it, right? It just knows how to generate one. So in this example, X would be a iterable. It's able to be converted into something that's iterable, but it's not an iterator because it doesn't have the next method. So therefore, all iterators are iterable, but not all iterables are iterators. Hopefully you can get your head around that. It's not too difficult to, hopefully though. Here's the example I just used. Lists are iterable, right? But they're not iterators until we call iter on the list. Then we have an iterator of the list. And loops only need to give, for loops only need to be given something iterable. It will turn it into an iterator for you using the _iter function or method. Cool. I think that's it for iterators. Yep. You can leave any questions in the chat. We'll have a 5 to 10 minute break. I'm going to go make a coffee. You guys can go make a coffee, get some water, and then we'll come back to discuss. But Pernjay's just got a question in. Does this mean lists are less efficient because they are not iterators? So I guess the question would be to less efficient than what? I don't see it that way. It's just that to start iterating over a list, it needs to be turned into an iterator. I suppose the reason... So can anyone come up with a suggestion for why lists aren't just iterators by default? I have a gut feeling as to why, but I'm not actually certain if it's true. Maybe during the break, if someone's just sitting at their computer, they can come up with an answer. But in some ways, I think lists are more efficient because they're not iterators. So the list, by default, before you turn it into an iterator, doesn't need to have some of this extra functionality around next, for example. It only needs it if it's been turned into an iterator. So it allows you to not have that bloat on the list until it actually needs to be turned into something iterable. So there's a little bit of overhead if you're going to loop over a list to turn it into an iterator, and then it's, then you've just got everything you need to iterate over it using the for loop. However, before that point, it's nice that it doesn't have the next method on it, because when you're passing around the list and doing things with it, you don't have to have that extra bloat on the iterable list. Does that make sense? So basically, no point having the next method on it unless you know we're going to be looping over it using the for loop, at which point we'll create it and put it on. So I guess, look, we're in very minutiae here. You could argue that there's an upside to a downside to this method. Because either way, you've got to either add it on or you already had it, for example. But I guess it's a good question. If you know you're going to be iterating over this list all the time, maybe you don't actually want the list, you want the list iterator. So turn it into the iterator and then pass that around. Then you don't need to turn it back into an iterator every time you want to loop over it. And maybe, just maybe, you'll save yourself some precious cycles every time you start looping over a list. Something to think about. So James, how would you have the squares iterator starting at 0 so that when you first call next, it starts at 0? Good question. Let me get rid of this. But basically, there's nothing special going on here. It's just an object, it's just code. We initialize this I value to 0. What you're saying is that, well, can I just return 0 times 0 first? So we'd have to say like result is equal to 0 times 0. Then we increment I, and then we just return that result there. And if we were to run this, let's just run it a few times. We would see 0 as the first value. So you have full control over what this is doing, but keep in mind that maybe in this case a square, the list of square numbers shouldn't be starting at 0 because of the mathematic connotations that would have. But it's just the order in which we returned it, basically, in this next. But we have full control over what it's doing. Next is just code that we write. Does that answer your question, James? And so this would be, returning just 0. Cool. All right, I'm going to go make a coffee. I'll be back in 5 to 10 minutes. Again, if you've got any leftover questions, put them in the chat. No problem. I'll answer them when I get back. Okay, we all good to keep going? Someone give me the word. Tom's back. Awesome. Anyone else? Oh my god, something's in my throat. Okay. Let me just clear my throat a little bit. Okay. Probably shouldn't have gone to sleep at 2 a.m. today. Oh, Tom. Yeah, sleep schedules are hard when especially if you're working online a lot. Alrighty. We got this. Second last lecture, Tom. And we're almost there. Alright, let's get into it. So, generators. If you understand what we were talking about a little bit when we spoke about the iterators, generators shouldn't be anything much more complex to understand. They are a different way of writing iterators with some different assumptions, I suppose, or preconditions in terms of what the thing is that you're wrapping in the iterator or the generator. So they are defined via generator functions instead of classes. So you don't need to use an object or to create an object with iter and next on it, for example. They are just created from a function. And we can just create, define functions in our code sort of ad hoc that create something that is a generator. So this is a really simple generator here. We say define simple generator. So simple generator, is a function that we write that returns some code. That code uses this yield keyword that we haven't really come across yet, I don't think, as well as doing some things in between the yields. So you can think of a generator as a suspendable computation. Calling next on the generator, the exact same way we call next on an iterator, executes it until it reaches the next yield, at which point it is suspended until the subsequent call to next. So knowing that, let's go to the simple generator example over in our text editor. Let's make this full screen. Let's open up the Explorer. Let's get a, not square, let's generate a basic. This is good. Okay. So what have we got here? We've defined a function that returns some yields, some code, or that executes some code containing yield statements. So let's talk about a yield a little bit. A yield is sort of like a return statement, but it doesn't end the execution of the function. Okay, so this will yield something called apple, and then instead of just ending the function and clearing out that stack frame, it just pauses, it's frozen, until next is called again, and then it will run some code until it yields the next value, and that'll go on and on. And we use, the way we interact with it is exactly the same way that we interact with our iterators. So for example, so we have this function called shopping list that yields apple, orange, banana, pineapple. We run for item in the shopping list, print that item. We know from when we deconstructed the iterator that what happens when we do this, we break down the shopping list and we call next on the iterator or the generator over and over until it ends, right? Do we agree with that? So, if we look back at this iterator demo, or iterator loop, I guess. I think, yeah, this one's fine. What we're really doing is we're just looping and calling next each time the loop runs, okay? And the exact same thing is happening with the for loop using the generator function. We call next each time. But so maybe an easier way of demonstrating this is that instead of just calling, using it in a for loop, we just call print next of the shopping list. However, I don't know if this will actually work. Let's find out, actually. I don't know if I need to turn it into a generator first, I guess. Oh no, just print it like that. All right, so what this will do if it works, it will print 1 and then yield apple, and then we'll print apple because we print what's being called in the next. So we go Python generator basic, we run that. Hold on, I'm in solutions. I gotta fix that. Okay, sorry about that. So we get exactly what we expected. Number 1 gets printed. So, and then apple gets printed. So what's happening here? We have this shopping list function. The shopping list function is a generator function. When we call next, we execute the function. We run the first line of code. Is the first line of code a yield? No. So we do what it says. It says print 1. We get the 1 printed out. All happy so far. Because it wasn't a yield, we execute the next line. Is the next line a yield? Yes, it is. So apple gets returned. Now the function does not end because it's a yield, not a return. So that apple comes back to the next function. It gets returned. And we print it out, so we print out the apple, and then that's it. We pause the state of the shopping list generator, which means if we call it, actually, I don't know, this might start it again at apple. Let's see. It does, because we generated a new generator here, okay? So we didn't turn the function into the generator object, we're starting it each time, which is why one an apple is getting printed out. So if we want to interact with it how we would expect, again, a generator is something that the for loop knows how to interact with. It will turn it into a generator object rather than just creating a new generator each time. So we can just use the for loop, the syntax that we're all familiar with, for item in shopping list, print the item. When we do this, we see what gets printed out? Let me just clear it and run it again. 1 an apple, 2 an orange, 3 an banana, 4 an pineapple. So it's a really interesting way to create something like this generator. And we'll talk about some more practical examples in a second. To be 100% frank and honest, I've never created a generator in Python myself. I've never had the need to do it. I'm not saying there's no need to do it. It's just not something that I've had to do. Iterators I have, generators no, but that could just be because I'm not a very good Python developer, I guess. There's probably specific use cases where it's really handy, you know, where you're yielding things as they come in via a stream, for example, and you don't exactly know when it's going to end or what all the data set is. So I can see when you would use it. I've just never used it myself. But it is really interesting how it works. Let's go back to the slides. Okay, so that's basically the example that we went through. We already spoke about this as well, didn't we? So you can think of a generator, suspend all computation, you call next, you run the code until you get to the next yield, and then we suspend it and we call next again. Okay, we can look at a bit more useful examples here. So we can turn the squares example into a generator. So let's see here, squares generator. So this is a generator now that will yield the square numbers, just like we were doing with the iterator. But what you can see here is that it's much less boilerplate code. So I can just say for square in squares, print square. Now this is called square generator. Oh, okay, and again, it's not going to stop. Let me just cut that off. It's not going to stop because I didn't build in any way for it to end, but you can see here that it's looping through as fast as it can, generating each square, which is pretty cool. And then we can do this exact same thing with Fibonacci numbers. In fact, I might already have, not really. But we can just really quickly, whoops, it doesn't like copying from these slides. It says copied, and it just doesn't copy. What if I do it like this? Okay, yeah, you gotta do things yourself if you want them done right, something. We put fib here, say for f, while true, it's going to yield it, and then we can just say, if f is greater than 1,000, break. All right, square. It's still called square generator, but you can see here now that it's generating the Fibonacci sequence using the Fibonacci generator function. Pretty cool. Something different, something interesting that we've learned here. Any questions so far? Again, chat's really quiet. Pretty neat, I suppose. Yeah. Alrighty. I don't really need to talk about this stuff. The next library stuff. But I suppose the point of this slide is just to say that many library functions can package up, their own generators and iterators. And the cool thing is that if they're adhering to that signature, you can just use the for loop syntax to interact with it and go to the next one. All right. It's quiet because nobody's talking. Well, maybe at the end of the lecture, Tom, we can chat about Elden Ring. Okay. I think that was it for the iterator code. Let's see if there's any any questions on it, I suppose, feel free to ask, as always. Anyone else other than Tom? Not that I don't want Tom's engagement, but any other questions or anything like that? Do we see the use of it at least? Maybe you can't think about, what you would do with it right now, but damn, that coffee is so bitter. Okay. All right, we have 30 minutes left. I had one more slide deck to talk about, but it's, again, sort of just meant to be a little bit inspirational and interesting, but not necessarily related to the assessment in the course, although it is, of course, related. So we're happy to just move on to that, I suppose. Oops. Okay. So, stepping away from Python for a second now. This is a really small slide deck, so it's likely that we're just going to end the lecture a bit early. So, this is a topic that falls within the software development lifecycle sort of mini series of lecture content that's all about how modern, I guess, really startups, which some of you may go to work in a few years, which is really exciting. How modern startups, or one philosophy behind modern startups that they use to generate a lot of value, and the right value very early with the minimal amount of cost. So this author, Eric Ries, produced a very popular book known as The Lean Startup, focusing on methods to shorten the production development lifecycle and determine if a business is viable or not, more rapidly than traditional philosophies may have resulted in. And because you're doing things in a shorter time period, that means less cost, less wages, less technical debt, for example, because you're doing things quicker, using a build, measure, learn sort of cycle and principle. So one way in which, if you're doing something now, this doesn't just need to be that you are at a startup and the management is telling you to use this philosophy. It could be that you're working on it on your own project, and you want to do things in the right way, with the minimum amount of sort of time going into it, with the maximum amount of value or output coming out. So one of the tools that these startups now use is something called the Lean Canvas, which we'll show in a second, which is used to try and articulate the core principles of a business. And again, it doesn't just have to be a business. It could be any problem that you're trying to solve. And I'll talk about some examples in which I've applied these concepts as well. So these canvases can then be used to inform what to build. So it's really easy to get, especially if you get a bunch of developers together, it's not just one person, it's really easy for people to be working on things that they don't really need to be working on at that point in time. So if you ever want to start a business, this is a really good place to start. And this isn't just me saying this. So this particular slide deck came from Hayden Smith, who you met 2 weeks ago, I guess. Yeah, 2 weeks ago. Who is CTO of a pretty successful startup that's growing in success sort of every week, which is really, really exciting. So it's not just one or two people saying this. So this is an example of the Lean Canvas. There's a bunch of tools that you can use to jump on and get the template, but you can see that the template's not too complicated. But the way it's structured is sort of important, and it gives you a bit of guidance in terms of how to sort of fill it out and think about things the right way. So, logically we start on the left. What are the top 3 problems that you're trying to solve? Limiting these problems to 3 is really important, because if you get a laundry list of things you want to solve, it's overwhelming, you don't know what to focus on, you don't know what's important. So keep it to 3. And then start to think about, well, how could I solve, what features do I need to solve these 3 problems? And so these are the 3 solutions that directly solve those 3 problems. I guess you can see my mouse, can't you? Yeah. These are the 3 features required to solve the 3 problems that I've listed in my problem list. And then how do I know that I've solved those problems? And that's what your key metrics are. What activities will you engage in to quantitatively measure that the solutions, I suppose qualitatively could be okay too, but so you could survey or do something there. But you need a way to know that you've actually solved the problems, and you need to predefine it. Like good research, you can't just make things up as you go. You have to, when you're sitting down to write this canvas, write down the things that you think will determine whether or not you've met the problems face on. Now we go into some of the more qualitative aspects of it. So what is your unique value proposition? What differentiates your solution or your business or your startup or your company or your tool from what's already available? Write down the sentence or the two sentences. What's the message? Why are you worth investing in? Why are you worth buying? Write the unique value proposition. And then think about what things you have available to you to achieve all of these goals. And one way of thinking about this is, what's your unfair advantage? What can't be easily just duplicated? Because if you come up with a great idea that's easily duplicated, someone will just come along and really simply spin up a competitor cheaper than you can do it, because they might have much more contacts and things like that. To do that. So you need to come across with an idea, what is some unique IP? Maybe it's some legal protection, maybe it's someone on your staff, maybe it's you, anything that can't be easily copied or bought. And then how do you reach your customers or your users? What is your path? Are you going direct to consumer? Are you going through some third parties or something like that? And then on the far right, who are your target customers? Who do you want to be reaching? Types of users that do X or Y, for example. Underpinning this whole canvas is then how you're going to fund the project. So on the left-hand side, the product side, we have the cost structure. How much is it going to cost to do all the things you need to do to build your 3 solutions to solve your 3 problems? And how much does it cost to pay your staff wages, to acquire new customers, for example, advertisement, to distribute, to host it. So how much is your AWS bill going to be, for example, and people, of course, which is the staff costs. So that's how are you going to fund your product? And then how are you going to earn money from your product? What's the revenue model? What's the life cycle? What's the margin? All of that, the tax, and what is the market that you're operating in going to require? And this is sort of just a really simple way to think about a very holistic approach to starting up something that's got some financial backing, or requires some financial backing. And so again, it's not to say that the scale of this needs to be massive. It can be quite small. But it's useful to think about all these different avenues. So Pernjay's got a question. I want to start a business, so data analytics, machine learning. How can UNSW help me? Great question. UNSW is very unique in that we have, I think this is what it's called. Yes, that's what it's called, UNSW Founders. So, I hate when Chrome does this. So UNSW Founders is basically a mini company within UNSW, designed from the ground up to support entrepreneurs and people like all of you and people like Pernjay to build a company. There's many details on the page in terms of things that are available, from all the way from funding to makerspaces, to coursework that you can actually study that specifically support in teaching you certain things that you might not be familiar with, so business sides of things, to competitions, all the way to working with researchers like myself to commercialize products, to accelerators. You can see there's a lot of, this is amazing. There's a lot of cool stuff. And there's a lot of examples here of companies that have come out of UNSW Founders. So for example, Yellowbox is one I've used personally. Has anyone been to Coogee Beach? There's a bunch of lockers that you can, oh my God, stop scrolling, that you can go to and put your stuff in it while you go for a swim, and it keeps your stuff safe. But so yellow box is really cool, and it's come out of UNSW Founders, for example. There's a bunch here, and I think I'm not certain. Maybe I don't know if I should. Oh yeah. There it is. So Hayden's. Oh my god, this scroll is a killer. Hayden's startup Perla, which is, if you're not familiar with it, and again you met Hayden last 2 weeks ago. Hayden's startup, which is a micro investment app. I don't want to call it the wrong thing, but that's what I think it is. Came from UNSW Founders as well. So UNSW Founders is available for students. I don't know if I made that clear. It's not staff. So you're all able to engage with these people. Whether or not they'll back you, I don't know, but they might give you some guidance for how to get started. So UNSW Founders, I think, is the place. But before you even contact these people, you need to have your core idea, a bit more formed. So yeah. If I don't have I guess you mean permanent residency, Steve. Can I join these? I have no idea. So just reach out to them, I would say. A lot of projects say permanent residency only. Where is that? Where does it say that? It might do. I'm not sure. Probably. But there still would be some ideas and support and things here. Yeah. I'm not too sure. What are the other questions? Alex, CSC needs to buy some AWS computing power to run our pipelines at the last night before it's due. Okay, a bit of, yeah, I get that. I've been pushing for a better infrastructure for that. Yeah. Cool. Probably research. I don't know what the context of what you mean there, Alex, is, but Felix, are there hardware startup supports? I have absolutely no doubt that there's anything preventing. Well, for example, Yellow Box is hardware. Yellow Box is hardware. So I absolutely I bet that there's ways that they can. I mean, I don't think they really care what you're doing. It might be hardware, software, whatever. It's about supporting startup founders and businesses that you can go off and build. I don't even know what neuroffic research is, but if you've got a really good idea and you've built a minimum viable product, which is what we're sort of talking about in this lecture series, build a minimal viable product. If you've got an idea for something you think it's really interesting, get a bunch of students together. Maybe wait a few years until you're in second or third year, and just do it. I mean, you guys are in such an amazing position in that the university you're at and the students you're working with. You might get a bit shitty with me and with 1531 in that you think it's a lot of work and it's demanding, and maybe the pipelines aren't perfect and things like that. But you are at one of the most amazing institutions in Australia with the most amazing students in Australia. If you look at what Hayden did with Perla, his company, they were all, I think, UNSW students that he interacted with while he was at UNSW, and this is a quite successful startup that's growing every day. So utilize, we put you in a bit of a pressure cooker, but utilize the result of that, which is the people you're working with, the people you've met in 1531, and the people that you'll continue to meet in your later courses. Get together between terms or in the break, build an MVP, and then you have things like UNSW Founders that you can go to, and they will, they'll give you support and read everything up here in terms of what they think you should be able to build in order to get, take it to the next level. And then when you're filthy rich, just give me like 1%. Yeah, that seems fair to me. 1%. I'll take 1%, like just stock in your startups, in your companies, and we'll call it fair. Does that sound fair to everyone? But really, I mean, if you think about what you've been able to do in 1531 when you've built the Seams application, you built that in one course of one first year course. Right, let me rephrase. What you built was 4 or 5 of you who had potentially never met in only one first year course. Yes, there was lots of guidelines and we gave you the spec, but look at what you built. I mean, in many ways, you went beyond a minimal viable product. If you're able to do that now, think about what you're going to be able to do in 2-3 years. And yes, many of you will go get a internship at a big software company and you'll be really happy. But for those of you who have a bit more of an itch to create something from scratch, keep pushing every single day, ask lots of questions. But Steve, maybe founders won't be available for you without a permanent resident. But what we're giving you in 1531, for example, and what your courses are giving you is not things like this. It's the knowledge and the ability to build things. You built seams without a permanent residency. Yeah, Python didn't say, please enter your permanent residency code before you can unlock this feature of iterators. You can build anything. It doesn't matter where you are. That's the true sort of, not gift, what we're trying to do here. So when, this is what I'm trying to get across is that yes, 1531, maybe the iterations are sort of heavy duty in terms of what we expect, but in a few years, you're going to be, you want to make a service that's available as a web app, you're going to need an API and you're going to think, I know exactly what that's all about. I did that in 1531. I can build something out in a weekend using Flask and I'm going to have an MVP to you in a week. And then if there's a few of you that have those abilities and those skills, and a lot of you will because you studied at this amazing institution, doesn't matter where you are in the world, you'll be able to do that. And then if you are available to receive some of this support here, there's amazing support available at UNSW, but even in your own countries or wherever you have permanent residency, there'll be equivalents, I'm sure. I guess, okay, last thing I'll say is that, I was going to say it tomorrow, but maybe I can say it twice, is that now that you are at this point in your studies where you're not just learning basic programming concepts, but now you're actually building things with those concepts, what I really want to push you to do, and I think what really served me well in my career so far, as I keep developing, is that start building stuff now. Don't just wait and get told what to do in your next course. Be really curious and start working on real problems and real tools, even if it's just a small tool to help you do something. Never stop, pushing that forward, and that's how you're going to become the next level of developer. Now it might not, we will teach you in your next courses specific things and theoretical foundations and things that you wouldn't have come across yourself and you wouldn't be able to maybe teach yourself. But in terms of this general software engineering push, it has to come from you. So I'll give you an example of what I'm doing in sort of my own things is that, if you notice that we had a few issues with the lecture slides this term. So I'm building my own lecture presentation system like slides.io. But basically it's all open source and I can control it myself using Markdown. So this is what I've slowly been working on. So what I can do, if I just minimize this a bit, and I suppose, we're sort of at the end of the lecture. So if you want to head off, if you've got a lot of things to work on, that's completely fine. If you just want to hang around and have a quick chat, that's also fine. But so for example, I can take this plain Markdown file here and just say, hey everyone in 1531 lecture 10, save that. I can get rid of this, save that, and you'll see this lecture slide basically live update based on that plain text file, so that I can really easily write lecture slides and then the other thing I was working on with this as well, if I'm writing C code, maybe I want to actually execute it in the browser, and so I built a system to do that. It won't run right now because I didn't run the backend server, but this is just an example. I'm not saying this is going to make lots of money, but you are in a unique position in that you can build things now. So go and build things and solve problems for yourself or for other people and make lots of money. And then just give me 1%. That's it. I think that's fair. Cool. Any final questions for this lecture today? Nope, thank you. Well, thank you, Felix. Thank you, Steve. Thank you, Penjay. Thank you, Tom. Thank you, Alex, and everyone else who's joined. If you haven't completed the My Experience survey, please do that. Otherwise, I'll see you tomorrow where we'll discuss the exam. I'm sure you'll all attend for that. But don't stress too much about that. Thank you. I hope you learned something today with the iterators and generators and some Python stuff. And then I hope you got a bit excited about, going forward. I know you're all exhausted after 1531. But I hope you can keep some fire in you to be excited about what you can go off and build, in your own, to solve your own problems or to solve other people's problems in a startup or a company. It's really exciting. Yeah, I'll see you on campus. I am sort of on campus now and then. So maybe we can, let me think, maybe after term or something. Time to handle Lando. I already beat the game, Tom, so you're far behind. Go play Elden Ring, look after yourselves. No more iterations, really exciting. Just the exam. We'll talk about the exam tomorrow. Thank you. Have a great day. Look after yourselves. I'll see you tomorrow for the final lecture. So sad.